Good afternoon. Welcome to session 3. And in this session, we will see how to solve a PD by Lagrange method. Even in lecture 2, we have seen how to solve PD by using Lagrange method, which you can see this. I hope you have watched my previous video. Okay, there we used to solve, we are given a quasi-linear PD. Consider Lagrange method dx over p equals to dy over q equals to dz over r. And by some certain or little modification, we try to convert into variable separable form. Okay. So now here, sometimes the problem will not be that easy that we can do some kind of manipulation we call component or dividend kind of thing. Okay. So basically we choose functions. Okay. So let's say you are given a PD again, and this is your Lagrange auxiliary equation. Now you need to find out functions. Okay. You have to choose. These are called as multipliers, but here multipliers are not constants. They are functions. Okay. And so instead, this is nothing but dx over p equals dy over q equals to dz over r, and now you will choose three functions p1, q1, and r1. Multiply each one of them, like you have seen them in component or dividend. Like if I have a by b equals c by d, then I know that this is equal to a plus c upon b plus d. This is componendo. Okay, the same manner, if I multiply by a constant ka plus some tc, then this will be equal to kc some bt. Okay, this is what my componendo dividendo thing is. So in the same manner, instead of scalars, we will have functions here. Okay. So there is no issue multiplying, but what if the denominator becomes 0? In that case, we need to discuss. So as we know that this all ratio, all of these fractions will be equal. So we are going to this over r, and this will be equal to this quantity. Okay. So the real question is, what if this quantity becomes 0? Because that's our goal is. Okay. So what if the denominator p1p plus q1q and plus r1r equal to 0. Okay. If this denominator is 0, so if you consider this denominator 0, not something upon 0 will give you infinity. It's a kind of ratio. So this 0, when it is equated with any of the parts, so this it will make this numerator 0. Okay. It will make numerator 0. Okay. This implies if the denominator is 0, it will make numerator even 0. So q1 dx plus q1 dy and plus r1 dz will be equal to 0. And now you need to simply integrate. At this time. So this looks very messy quite, but it's not. Okay. So let me take a simple example to understand it, what I have been saying throughout. So let's say I give you an example here. Example 1. Say solve this PD. So that times x plus y equals, sorry, not equals, it is addition, plus z times x minus y times p. In this p q. Okay, and this is equal to x square plus y square. Suppose you are given this PD. Now, again, you will apply the method of Lagrange. So therefore, by method of Lagrange, you will say dx over capital P equal to dy over q equal to dz over r. So from here, you get dx over z times x plus y equals to dy upon z times x minus y equal to dz upon x square plus y square. Now, what scalars should I choose so that if I do this, I need to use this dx, dy, dz together. Okay, so I need to choose scalar so that this denominator becomes 0 after adding or subtracting. Okay, you can add or you can subtract. There is no restriction over addition and or subtraction. So subtraction is nothing but the negative of addition. So you can play with constants. But here constant will be your this constants. Here I'm saying scalars, but these scalars are not scalar normal. They belong to real. Okay. Here P1 does not belong to R basically. Here P1 is a function of x, y, z. So you need to find out suitable P1, Q1, and R1. Okay. That means, see, one thing it can be noted here. Suppose I do remove this here. If I remove this here, plus y and this is x minus y. What if I multiply this quantity here? Well, just a moment. For explanation, I'll consider writing in blue. Suppose I'm given this. So it's called the exponent times x plus y equals dy over z times x minus y equal to dz upon x square plus y square. What if I do this? I multiply numerator and denominator by x, and this one by y, and this one by z. Okay. Numerator and denominator both. And now just add them. See what you get. X dx plus y dy plus z dz. It's not necessary that you will always have to add, but it's the general practice. Sometimes you may need to subtract this part or you may need to add this part. So you just have to see. So it's just relative. That's why I'm writing in just to check things go wrong. I'll erase and I'll do another thing. So zx square plus zxy and plus xyz, and then minus zy square, and then plus zx square and plus zy square. So one thing is clear that I'm getting all the required fractions, but only thing is that I have not taken these constants together. So this will not be plus now, because if I add all of them, they are not getting cancelled. So I need to see zx square and zx square is here. So I need to subtract this part. That is confirmed. So this will be subtracted and this part will be again minus. Okay, this will be minus now. We anyhow need to make them 0. Okay, so now this will be fine, minus of z. And now I have to get rid of this y thing. So even here it is addition, so it should be again subtraction. So it will be even again minus. So this part will be minus and this will be plus. Now is it getting cancelled? Something. Zx square, zy square, yeah. Yes, now it getting cancelled. Zx square with this one, zy square with this one, and zxy with this one. And now see, you will get this numerator equals 0. After this step, you will get numerator is equal to 0. Okay, so now you can simply integrate see x, y, and z, and you get your first constant. And similarly, you have to play the next game. Okay, because we need at least 2 pairs. Okay, so let's confirm what we have written in rough work. This thing will now make it perfect. Okay. So whenever you get any problem of this kind, try to see if the denominator is 0, or if it is not 0, it will be adjusted in the numerator with some kind of function or its derivative. Those kind of problems also we will see, so you don't have to worry. It will be incorporated. So here we go. Now we already know that this thing is nothing but the addition. So it will be x dx and minus y dy and minus z dz. I multiply by the constants. So now again this will be z x square and plus z y square. No, xy, and then plus, and no, I'm adding. So it will be minus xyz. This is minus, and because of this minus, it will be plus. So it will be plus xyz, and then this is subtracted. So I'm multiplying by z here and here. So instead, rather I'll write down for your reference so that you know it better what I'm doing here. I'm multiplying here by x, here also by x, here by y, here by y, here by z, here by z. And now I'm performing componendo. So it will be getting cancelled. Now this will be minus zx square and minus zy square. See, all of them are getting cancelled at one go. I think I did not write one term. Yes, minus zy square I did not write. So it will be plus zy square. So this part will get cancelled with this, and this with this. This is the first one. All of them got cancelled. But wait a second. I wrote it extra. It's not needed. This part is done. Okay. So all of them are getting cancelled. So now, because of this thing, now this part is 0. So you can say that take any of them. Okay, take any of them. Take any of them, because it is ultimately going to be 0. So you don't have to worry. So you just have to write down x dx minus y dy minus z dz over 0. Correct. This is what I've got. You can write down here any pair, whatever you like, first, second, or third. Okay, because ultimately it's going to produce 0. Okay, because the ratios are has to be same, so this quantity has to be 0. This implies x dx minus y dy minus z dz will be equal to 0. And now simply integrate. Now simply integrate. So you get this will be x square by 2 minus y square by 2 minus z square by 2 equal to c1. In fact, write down 7 by 2. So from here I'll be getting x square minus y square minus z square equal to c1. One function I got. Now I need to find out the another one. So I need to choose again these function multiples, but they should be different from this one what I've got, because I'll get the same function then. Okay. So now again consider the three pairs and try to think of some different scalar functions in fact. So x plus y equals dy over z, x minus y equals dz over what is that, x square plus y square. Yeah, perfect. So let's see if I can try to cancel things. Okay. So what can I think of it? Okay. So it will be a kind of rough only, and most of the time you will feel the first thing remains same. Okay, you need to multiply x with x, y with y, z with z, and sometimes you need to perform a different game. Let's see if it works or not. Okay, so it will be a rough work basically, so that you understand it. Okay. So this is x square plus y square, zx plus zy. Suppose I ignore this z and I'll multiply by this yx. Okay, we got it. In fact, this is y dx and plus x dy. First, let us perform this much, at least. And I'll keep this space for z because I don't know what constant will be included here. So first do this. I'm multiplying here by y. So first term will be x, y, z, and second term will be z, y square. And I perform x plus zx square and minus zy square. Okay, well, this is perfect. And I think this part should be subtracted then. I'll multiply by z now. And I'll add subtract it in fact. Because if I don't subtract, then I'll not be getting, this thing will not get cancelled. So I'll multiply by z and then take this part also. So it will be minus zx square and minus zy square. So something getting cancelled or not? So, just a moment, we are again in trouble. More trouble is on the way. So zx square, zy square, zx square. I made a mistake. It's not zy square. It's zxy because I'm multiplying with x. So it will be zxy. All items fine. So zxy getting cancelled with this, zx square getting cancelled with this, and zy square getting cancelled with this. Yeah, lucky. Okay, so this part I'll not include. I'll do that right now. Now I know the constants, so it will be simply this ratio will be equal to y dx plus x dy minus z dz. On I know that this part will get cancelled, so it will be 0. Okay, so just consider any any two pair, first, second, third, fourth, but better first and fourth. So consider dx on z times x plus y will be equal to y dx plus x dy minus z dz on 0. So then this part is 0 numerator, so this denominator is 0, this forces numerator to be 0. This will be equal to 0, and now simply integrate. Okay. So let me erase this first, because at the end when I upload the entire PDF, then there are chances that you may get confused that at the next step, why am I integrating this? So this will not be good. And now I'm integrating, so I'll be getting here. Oh, we are in trouble again. But once again, we are in trouble because we cannot directly integrate. We cannot directly integrate here because here y is there, it's a function of x here. Here it is x, it's a function of y. But for z there is no issue. So what I'll do instead, I can see that this thing is nothing but d of x into y. Okay. Derivative of x into y, it will be y will remain here. Derivative of x plus x will remain here. Derivative of y minus it will be simply z dz equal to 0. Now integrate. So this integration and derivative will compensate each other, and it will give me just xy, and this part will give me minus z square by 2 equal to c2. Okay, now just multiply it here. So 2xy minus z square equal to, this is a constant 2c2. I'll call it c2 dash. Okay, another constant only. Instead, let's call it c2 dash, and this will be c2. And just write down here, c2 is nothing but your 2c2 dash. So I got this thing. Now phi of c1 comma c2 equal to 0. Suppose if phi of 2yx minus z square comma x square minus y square minus z square equal to 0. This is the solution of this PDE. Okay, so we're done. Now let's try one more. So I hope you are getting the tone to solve this problem. So mz minus ny into p plus nx minus lz cube will be equal to ly minus mx. So you can pause the video and try on your own. Meanwhile, I'll supply the solution. Now this thing will give me dx on p is my mz minus ny equal to dy over will be nx minus lz equal to dz on ly minus mx. So what can I think of doing to cancel this? My goal is to cancel them. So I'll go with the first step only. Solution that I do is multiply here with x, here with x, and see what happens. Here with y, here with y, here with z, and here with z. This addition and subtraction thing will depend how you carry it out. So it's better you just check it roughly. So just watch out x mz minus x and y, and then it will be x and y and minus L Z Y. This one I have, and then I have Z L Y minus M X Z. Now you just see what sign should I put up here so that all of them get cancelled. So X M Z and minus X M Z and minus N X Y. This should be plus, and again I think this should also be plus. Let's see. This gets cancelled with this thing, and X N Y will be gone, and L Z Y will be gone. So we now need the notifications. So I can directly say that instead I must delete this entire quantity because I don't need it. Zero, so just stick in there, and then in the next step right now, so this quantity right here will be equal to, that means I'm getting dx upon mz minus ny will be equal to dy upon nx minus lz will be equal to dz upon ly minus mx. This thing will be equal to, now I know that I just added all of them. So x dx plus y dy plus z and dz. Roll upon this quantity becomes 0. That's I have done separately. So now consider any of them. You can consider even a single pair that will work, and equals to x dx plus y dy plus z dz upon 0. This implies this numerator is 0. So x dx plus y dy plus z dz equals to 0. Now integrate it. X is with x, so we don't have to worry about that term. And now this thing will be 0, so integration 0 here directly. So here you get x square over 2 plus y square over 2 plus z square over 2 equal to c1 over 2. So from here you get x square plus y square plus z square equal to c1. I got one. Now in the same manner I have to confirm another one. So consider dx over mz minus ny equal to dy upon will be nx minus lz and it will be equal to dz upon ly minus mx. So now let us choose another constants and see what we get. Now I'm planning to cancel them. So just a moment, this is mz and this is zl. So what if I multiply this one by l and this one by m? So if l, of course, this will be multiplied by n. Now let us see the effect. What will happen here? If the denominator becomes 0, then I'm happy. Otherwise, I'll think of some other constant. So that I'll write down the operation here itself. So it will be L dx and m dy and n dz. I've not written addition or subtraction because I want to see what role I have to play. So it will be L mz minus L n y and then m n x minus m l z. So one thing is confirmed. This is lmz plus, this is minus. So I have to add this quantity. These two will be added. Now let's see what will happen here. So it is again n l y and minus m n x. So of course this one will also be added. Okay, so we are gone now. Getting cancelled all of them. So now I know that you can consider any of them, but I usually have the habit of writing the first one. Equals L dx plus m dy plus n dz the whole upon this will be 0. And now in the next step, what you can do, you can simply write down L dx plus m dy plus n dz equals 0. Now simply integrate. So integration over L dx plus m times integration over dy plus n times integration over dz equal to integration of 0. This one will give me Lx, this one will be my plus mz equal to c2. So therefore, phi of c1 comma c2 equal to 0. This implies phi of x square plus y square plus z square comma Lx plus my plus mz equal to 0. It's the required solution. So I hope you got it. Okay. If you haven't, I still have a problem. So we'll solve one more so that you polish it better. So you just have to play with this functional constants, nothing else. So let's solve third problem. Sometimes it will not become 0. Okay, even there is still a possibility. So let's consider this one and see how we'll be getting here. Z square minus 2yz minus x square into 3 plus xy plus zx into q equal to xy minus zx. So you can try solving this one. Now here, see, sometimes it may happen that it will not become completely 0. Okay, so you don't have to be disappointed. Okay, you don't have to be disappointed. You still can complete the problem. Just think this. Dx Alright, so now let's start down here. So dx over what is my capital P? This quantity. So that means I have here z square minus 2yz and minus y square. Now this will be equal to dy upon. Next I have is xy plus zx. This will be equal to dz over xy minus zx. Perfect. Now watch out. This is 2yz, and here I have where it is yz. So what should I do? XYZ and XYZ. Okay, perfect. So I'm not getting any idea. So I'll just try if it works. First multiply by x and c, and then multiply this by y and c. Multiply this by z and c. First, let's see what will happen. So you don't have to worry about the numerator. We just need to check denominator. Just need to check denominator if it is 0 or not. If it is not, still we don't have to worry. If it is 0, still we don't have to worry. So just multiply and see what you get. Xz square and minus 2xyz and minus xy square. Don't place any sign here. So just write down xy square plus zxy. And then you have zxy minus z square x. Now just watch out. This is xz square and this is minus. So ultimately this part will be added with this one. First one and third one will be added. Now second one, see, x square square, so it will be again added because I need to cancel them. So we are done. That means this first part, second part, and third part. We just have to add the denominator and see all of them getting cancelled. Xy square nicely with this one, and then xy and then xy. This is twice, and then I have here the negative of 2, so it will be cancelled. Even this one will be cancelled. I'll be getting this 0 complete. So I'm lucky. I got complete 0. So here this implies I'm getting. Rather, I'll write down this. Since I know that this is 0, so I'll completely write down x dx plus y dy plus z dz whole upon. I know that this part right here I have done here, so I'm getting 0 here. Okay, so for the reference it is. Now consider any part. So let's consider, say, dx over. Well, I don't want to write down this big equation, so I'll consider the smallest one. So dy over xy plus zx, because ultimately this is going to be 0. So x dx plus y dy plus z dz on 0. So from here, this is forcefully implying x dx plus y dy plus z dz equals 0. So one can simply integrate now. So x dx plus y dy plus z dz equals 0. Now this part right here will give me x square over 2, and this one will give me y square over 2. This one will give me z square over 2, and this one will give me c over 2. This is a constant. I'm writing c1 over 2 so that I can get rid of this 2 because I don't like fractions. One function I got. So first part is done. Now my tension grows because I have to work for the second part again. Still something is pending. So dx over the big equation, that is z square minus 2yz minus y square equals dy upon, what do I have, xy plus zx, and then I have dz over xy minus zx. Let's see if we can manage. Instead, I'll not consider this part only because I don't want to getting any scalars. Instead, I'll consider these last two fractions. See here, you are allowed to do anything. Okay, you can take all three together, you can take just two together, and you can find out suitable multiples and try to make the denominator 0 and then solve as we have done. Or you can not make it completely 0, but still you can solve. Let's see how I'm doing here. So consider I'll take these two parts because I can see if I play a little with this zx, then I'm done. Watch out. So dy over xy plus zx equals dz upon xy minus zx. Now, can I do this? Um, wait a second. I can take x common from here. Okay. I can take x common from here, so it will be y plus z, and then from here I can take x common. It will be again y minus z. This x is getting cancelled. So just take this part here. So y minus z dy, y minus z dy equal to y plus z and dz. Now I cannot integrate it because I have here z, so I have to get rid of this. So either we just expand the brackets and check this one here. So one thing is sure that I don't have to worry about this part, this and this. So all I'm concerned about is this part. So rather what we do this. Keep unaltered parts at one side and take this one there. Now you must have got the idea what I'm going to do here. So it will be y dy minus z dz minus, can I write this? And I'm done. Watch out. Derivative of z into y, it will be z, and then derivative of y plus y times derivative of z. Now you got all of them. Simply integrate now. Sometimes it is better to make life easy by thinking less. So it will be y square over 2 minus z square over 2, and minus it will be simply zy. It will be equal to some constant c2. All right. So now, because there is no 2, so instead of finding and searching for this radar, I'll just make it 2xy equal to, I'll call it c2 dash, and then if I take this 2 c2 dash, I'll call it c2 now. So you can play with constants. There is no hard and soft rule for this. Now phi of c1 comma c2 is 0. So this implies phi of c1 x square plus y square plus z square, comma y square minus z square minus 2xy equal to 0. That's the required solution. That's the required solution. Alright. Now, okay. So I'm taking one problem from CSIR net December 2017 for 4.75 marks, and we will try our hands on this problem. So let's consider you are given x square p plus y square q equals z times x plus y. So by Lagrange method, x square equals dy over y square equal to dz over z times x plus y. Now let's see what game we can play here. So instead of finding the scalars, it is better to consider first two pairs, okay? Because this seems quite easy. This is differentiable function of, this is integrable function of x, and here with respect to y. So I'll consider first two pairs. Or integrate them. So am I getting minus 1 upon x equal to minus 1 upon y plus c1. Okay. So from here, what I can do, I can multiply by 1 minus sign, and then I'll be getting here 1 upon x. This will be plus, but again, I'll take it here. Minus 5. This is minus c1, so I'll call it some c1 dash. This is a constant. So I got this thing. And now, again, what can I do here? So instead, yes, I got one more. Consider it is dx over x square equals dy over y square equals dz over z times x plus y. What will happen if I do this? Take 1 upon x dx equals 1 upon y dy. Instead, I'll divide by y square, and I'll this one by yz. So z, yeah, I'll be needing 1 upon z basically. So in the numerator, it will be 1 upon z, and then dz. And in the denominator, see what will happen. I'll be getting here x, it will be y, and it will be x plus y. So now what if I do this? I'll add this 2 and I'll subtract from this. So I get this 1 upon x dx plus 1 upon y dy minus 1 upon z dz whole upon x plus y minus of x plus y. This thing will be equal with any of the fraction, so we don't have to worry. Okay. You can write down any. You can even write down this dy over y square. No one is going to kill you. Okay. And now this part will become 0. So this part is 0. This implies this numerator has to be 0. So this numerator has to be 0. Now you can simply integrate. So this will be log x. This will be log y. This will be log z. Equal to, I'll write down some log only. Okay, so this one I can write down log xy. This one will be log z equal to log c2. So what if I do this? I do log xy over z equals log c2. So this implies c2 equal to xy upon z. Okay, so I got one function at least. So therefore, phi of xy on z, comma, what's the first function that I've got is 1 upon x minus 1 upon y. So 1 upon x minus 1 upon y equal to 0. So with this, I got option A correct. Got option A correct, but no. I think option B correct, not A. I'm sorry. This is 1 upon x minus 1 upon y. And this is B. So B option is correct. And now this is 4.75, means more than one can be correct. So we need to find out other scalars which will even result into these things. So let me see if I can get those scalars or not. Okay, so at least this one I've got. Now we have to see what we can do. If I can play any role. Just a moment. What I've got so far, let me check. So we have, you get the idea from here only. So 1 upon x minus 1 upon y equal to c1, and what do I have? xy upon z equal to c2. So can I modify this and write down y minus x upon xy equal to c1? And this is what xy upon z it should be. So upon z, yes, I have written x here. This is incorrect. So we just have to manipulate the things and nothing else. Okay, equal to c2. What at the place of xy if I write down z c2 equal to c1, and keep it here. Okay, keep it the way it is. Now take this c2 here. So y minus x upon z equal to c1 and c2. I call it some c3, fine, and xy upon z equal to c2. And if you got these two functions, you can say that it will be phi of if you write x minus y, you write y minus x and y minus x, nobody cares, because if you multiply by minus, this will be affected. And constants are considered to be the hydrogen elements in PD. You can play with them, you can multiply, you can add, subtract. Okay. So you write down here x minus y because in the option x minus y is given. So x minus y upon z comma it will be xy upon z equals to 0. And from x minus y upon z, this will also make option A correct, because I think this was what I was marking, x minus y upon z. So option A is also correct. Okay. And one more thing. This half x minus y. This is also correct. And okay. In fact, what game should I play? If I write this way, okay, if I write this way, let's say first one. Now consider 1 upon x minus 1 upon y equal to c1, and I know that second one was x minus y upon z equal to c3. Okay, I'll consider them. Right. X minus, no, not x minus y, it is xy. I take xy equal to c2. From this, I can also construct a function like this: 1 upon x minus 1 upon y times xy over z. So ultimately, if I check this phi here, oh, okay. So instead of taking this one, I'll play a game here. This I can alter and write down this quantity as z upon xy equal to c2 dash. I told you can play with constants n number of times the way you want. Z upon xy. I did it. It's just I can take xy here, so that I can get one more option correct, and it will be option D. Watch out. I even got option D correct. That's why I did. Now this will not be correct, because no combination will give you simply z and 1 upon x minus 1 upon y. You'll never get it. Okay. So once you understood the way how to play with all these things, life becomes easy, and you can solve these problems as well. Okay. So in this video, that is sufficient. In our lecture 4, we will continue with Cauchy problem. Okay, so lecture 4 will be continued in Cauchy problem. Okay, stay tuned. If you like the content, you can subscribe, like, and you can share the channel. Okay, and thanks for watching.